We are starting on the unit circle, and the unit circle is going to come back to haunt us for the rest of our lives, basically, at least the rest of pre-calc. So knowing the unit circle is important. I also want you to know that I personally do not have the unit circle memorized. There are some of you that will memorize the unit circle, and that's okay with me. I'm not a memorizer, so I'm going to go through how to find all the stuff on the unit circle. But then after that, kind of it's up to you how you are going to remember it. If you're a memorizer, find the YouTube video. But I do think it's important to know kind of where it stems from. So if I'm looking at a unit circle here and I have one drawn, a unit circle just has a radius of 1. So I have r there, and I also wrote that r equals 1. And my angle here is theta. It's the reference angle. It's made with the x-axis. This is my x, right, because I move over x and up y. So hopefully you see that x and y. So if I take sine of that theta, sine is opposite over hypotenuse. And y over 1 is really just y. My hypotenuse on the unit circle is my radius, and that's 1. Cosine then is adjacent, which is x over hypotenuse. So it's just x, and tangent then is opposite over adjacent. So y over x. So any point on the unit circle could be described as the sine of it is y, the cosine is x, and the tangent is y over x. So that's where those things come from. These things you probably will memorize just because you're going to do it so often. But if you didn't know where it came from, it does come from being on the unit circle and using sine and cosine and tangent, those SOHCAHTOA things we know about already. So I'm going to bring you back to geometry, and we're going to talk about special right triangles. And I do have a purpose for this. I want you to see where all these numbers come from. So I have the hypotenuse of this square highlighted, and I want to call that length 1 because that is the radius on my unit circle, and when I lay this triangle on my unit circle, the radius is 1. So I'm going to maybe call this a, or maybe x, whatever you want to call it. I want to solve for those sides. So I'd say like a squared plus a squared equals 1 squared. So hopefully you see here that you have 2a squared equals 1. Divide by 2. I'm running out of room. So a squared equals 1/2. And when I take the square root of 1/2, square root of 1 over the square root of 2. The square root of 1 is just 1, so I can kind of erase that. But in math, we really don't like the square root to be on the bottom. So I'm going to do something called rationalizing the denominator, which you learned in algebra as well, but I get square root of 2 over 2. So each one of these sides is the square root of 2 over 2. And similarly, maybe slightly different, but the hypotenuse for this triangle is 1 here. And this is, I should have written this in. This is a 45, 45, 90 triangle. It's from a perfect square. And this is a 30, 60, 90 triangle that comes from an equilateral triangle. So this is our 60-degree angle, and up here would be 30 because this entire thing is 60 in an equilateral triangle. All three angles are 60. So I want to find this side over here. This is 1. When I cut this in half to make the right angle, I get 1/2. And then I need to find this side, which is, I'm just going to call it h for height. So h squared plus 1/2 squared equals 1 squared. 1 squared is 1. This is 1/4. So I need to subtract 1/4 from each side. So I get 3/4. Take the square root, and I get h is the square root of 3 over 2. Because this would be the square root of 3 over the square root of 4, and I know the square root of 4. So this in here is the square root of 3 over 2. So these things are important when I come to the next slide, and I'm going to keep going with what is happening here on our unit circle. We use these triangles every time. So this is my picture of a 45, 45, 90 triangle, and you can see that it's lying here on its side where this hypotenuse is 1 because that's the radius of our unit circle. And if we flipped back, and you can probably see it in your notes, I can't, this side length was the square root of 2 over 2, and this side length was also the square root of 2 over 2. So when we're thinking about sine, cosine, tangent of 45-degree angles, okay, the sine of a 45-degree angle on our unit circle, thinking about back to that first one, it's going to be opposite square root of 2 over 2 over hypotenuse, which is 1. Well, we don't really have to do that. It's just square root of 2 over 2, or the y value. And same for cosine of 45. It's the square root of 2 over 2. That's my x value. So the point upon which my 45, 45, 90 triangle lands is square root of 2 over 2 over and square root of 2 over 2 up. And those numbers come from those special right triangles in geometry. So I can also talk about a 30, 60, 90 triangle where this was 1, okay? And the way I kind of remember it, this is 30. This one is going to be 1/2, and this one's going to be square root of 3 over 2. And if you type in square root of 3 divided by 2 in your calculator, you're going to get like 0.87 or 88 something. Don't quite remember. And here I get 0.5. And why I'm showing you that is because when I think of a 30-degree angle, or when I think of this triangle on my unit circle, I always think of which side is longer, because the square root of 3 over 2 side is longer than the 1/2 side. And since this one's lying down, the longer side is down here. Well, to get to this point on my unit circle, I would go square root of 3 over 2 over and 1/2 up. So if I asked you for the sine of 30 degrees, you would say it was opposite 1/2 over 1, or just the y value, which is 1/2. And the cosine of 30 degrees is adjacent over 1, which would be square root of 3 over 2 over 1, which is just square root of 3. So how can we do this on our unit circle? And I'll have plenty of these for you to practice on. So when I'm thinking about my unit circle, I sometimes draw these triangles in like this. So let's do my 45, 45, 90 triangle first. And I know that at square root of 2 over, so I want to go to my pen, square root of 2 over 2, square root of 2 over 2 is my point for my 45-degree triangle. Now my reference angle tells me that this one here is also a 45, 45, 90, and so is this one, and so is this one. So once you know your first one came from, the rest are easy, because this one has the same points, but it moves backwards and up. So backwards is negative, up is still positive. To get to this one, I move backwards and down. Negative square root of 2 over 2, negative square root of 2 over 2. And then here, I move forward and down, so square root of 2 over 2, and negative square root of 2 over 2. So really, I only had to know that red triangle in there to get all these points. So something I kind of forgot to put in here were my points. This is 0, 0 here. So 0 over, or 1 over 0 up, so I need to erase that. 1 over 0 up. And then let's start counting by 45. So this would be 45 degrees. Add 45, I'd get to 90. Add 45, I think I'm at 115. That's not right. It should be 135. Because when I add 45 here, I have to get to 180. This one's 270. So let's see, 180 plus 45 puts me at 225. And then I get 270 plus 45 would be 3. That one's 315. Okay? And then at 90 degrees, this point up here is 0 over 1 up. Okay, you guys know how to find these on any graph. This would be 1 backwards, 0 up, 0 over 1 down. Okay, so those were our 45s. Let's go to a 30, 60, 90 triangle. So I'm going to start with this one because we did a 30-degree one together already. And at 30 degrees, the bottom is longer. So this is the square root of 3 over 2 over and 1/2 up. When you do this one over here, this is our 30-degree reference angle, but still that's 30 degrees less than 180, so that one's 150, and it's back square root of 3 over 2, up 1/2. Okay, so this one is add 30 here, we get 210. This is minus square root of 3 over 2 minus 1/2. Hoping you're seeing a pattern here. And this one here is forward and down. This will be 330. and forward square root of 3 over 2 down 1/2. So what we have left are the 60s. So the 60 degree is when the shorter side of our 30, 60, 90 triangle is on the bottom. So it's 1/2 over square root of 3 over 2 up. And that's our 60 degree. This is my 60 degree reference angle here. So this is 120. And I go negative 1/2. I ran out of room. Positive square root of 3 over 2. This one's negative, negative, right? So this is 240. Negative 1/2. Negative square root of 3 over 2. And then over here, my last one would be 300. And that's positive 1/2. Negative square root of 3 over 2. So I never have any of these memorized. Every time I have to draw a picture, I go back to my 30, 60, 90 triangle and figure out the coordinates and then figure out which quadrant is in to figure out the rest of it. So if I use my unit circle, asking myself things like this, what's the sine of 30? So if I drew myself a 30 degree reference angle, it would be here. I know that that's square root of 3 over 2, comma 1/2. The sine is the y value, so the answer to this is 1/2. Okay? Cosine of 210. So where is 210? This is 270. This is 180. So 210 is right here. And so I think that's another 30 degree reference angle. So it's going to be negative square root of 3 over 2, negative 1/2. And the cosine is the x value. Here are ones that trick everybody. The tangent of 30. I already have 30 up here. It's square root of 3 over 2. Tangent is y divided by x. And to do fractions, we flip the second one and multiply. So y is 1/2. And then I'm going to flip this and multiply like this. These cancel. And I'm left with 1 over the square root of 3. I need to be able to rationalize my denominator on these, so that's what I'm doing. If you need help with that, you need to go back and check out some videos. You could find a YouTube video on rationalizing the denominator, but this is the answer I want for tangent of 30. Okay? You need to be able to do these on a unit circle type test. Tangent of 45, well, my 45, 45, 90 triangle has square root of 2 over 2, square root of 2 over 2. So when I do tangent, I'm going to flip the second one. These cancel and I'm left with 1. Okay, so the tangent of the 45s are positives and negative ones, so that's awesome. All right, cosecant of 225. This one's super hard. So first, let me think of where 225 is. I think that's a 45 degree reference angle. So I know it's negative square root of 2 over 2, negative square root of 2 over 2. And I know cosecant is 1 over the sine of 225. So the sine of 225, start there, is the y value, which is square root of 2 over 2. To get cosecant, I need to flip it, so negative 2 over the square root of 2, and then rationalize your denominator. So I get negative 2 square roots of 2 over 2, and look what would happen here. I just get the negative square root of 2 as my answer. Okay, last one is tangent 90. 90 is right here, which is 0 over 1 up. And when I do y over x, I get something bad. This one is undefined. Okay, so unit circle is not about memorization, but it's about thinking about where those points are and being able to deal with them from there and being able to use them to find sine, cosine, tangent, cotangent, cosecant, any of those things on any point of our unit circle.